Hello everybody, it's Mr. Basil. In this video I'm going to be talking about using weight to calculate mass, and part of this will be at the basic level, other parts will be at the meats level, but we're just going to go ahead and get started. So as a reminder, while we're getting started here, that weight is the force of gravity. It's another way of just saying that. So just be aware of that, and we've talked about that Newton's second law talks about the relationship between acceleration, net force, and mass. So that's one way of writing this, or it can be written like this: force equals mass times acceleration. And so these are all just little reminders for us. So the first thing I wanted to talk about is if the mass is not given, then use the object's weight to find the mass. So what I mean by that is this. So if we're using this equation, force equals mass times acceleration, Newton's second law, we can make this match a more specific situation that comes up quite frequently. So if we say that the force that we're talking about is the force due to gravity, which again is weight, the weight is going to equal the mass times the acceleration due to gravity. And the acceleration due to gravity is 9.8 meters per second squared. So we'd say that the weight, or the force due to gravity, is the mass times 9.8 meters per second squared. Okay? And then a more general way to write that is like this. Force due to gravity equals mass times g, where g equals 9.8 meters per second squared. Okay, and this equation is on your reference sheet when it comes time for that. So what do I mean by this? Well, let's use this example right here. At what rate does your 40 Newton shopping cart accelerate? So we're going to solve this for acceleration if the net force is 60 newtons in the forward direction. So we know that we're going to solve for acceleration in the end. So we need to know the net force, which we have. This is going to be 60 newtons, but we do not know the mass. So what we have to do here is we have to use this equation that I just talked about. Force of gravity equals mass times the acceleration due to gravity. So if we rearrange this for mass, we get the mass equals, divide both sides by g, and we end up with the force of gravity, or the weight, divided by g. So this 40 newtons here tells us the weight. So we're going to plug in 40 newtons here and 9.8 meters per second squared for g. And we end up with, switch colors here, the mass equals 40 newtons divided by 9.8 meters per second squared. So just type that into my calculator and I got 4.08. But then the question is, what units do we have? Mass should be kilograms, but let's double check that. So I'm going to put kilograms here because I think that's what we need to do. We have newtons divided by meters per second squared. And a Newton is a kilogram times meters per second squared divided by meters per second squared. And so then the meters per second squared goes away. I'm left with kilograms, which is what I want in the end. Okay? And so I shouldn't have boxed that in because that's not my final answer. My final answer is going to be acceleration. And so what I have to do here is take this and plug that into my original equation. So I end up with, I'm going to erase this. Acceleration equals my 60 newtons was my net force, divided by my mass, which was 4.08 kilograms. 60 divided by 4.08 is 14.7. And I should get meters per second squared, but let's double check that. I've got newtons, which really is kilograms meters per second squared, divided by kilograms. And now this time, kilograms cross out. I'm left with meters per second squared, which is what I want. This will be my final answer.
Okay.
All right. So again, to recap, if the mass is not given, use the object's weight to find the mass. So in the end, this, what we did here, is probably like a good meets level question. Here would be a good basic level question. A car weighs 9,750 newtons. What is the mass? Okay, so we know that, force equals mass times acceleration, but more specifically, force of gravity equals mass times gravity, which this is 9.8 meters per second squared. So if I want to solve this for mass, I end up with m equals, divide both sides by g, the force of gravity or the weight, divided by g equals the mass. So then I substitute in what I know, which the weight is 9,750 newtons, divided by g, which is 9.8 meters per second squared. I do 9,750 divided by 9.8. That gives me 994.9. Mass should be kilograms, but if we double check, a Newton, same thing as kilograms times meters per second squared, divided by meters per second squared. Meters per second squared go away. I'm left with kilograms, as if I did the right thing. Okay, so this would be basic. And this would be meets. All right, thank you for listening.